Hello all, this is the presentation for CS 542 Neural Networks course. Our project title is Finding the Sweet Spot, Optimizing Efficient Net Model Size for Accurate Dog Breed Classification. Team members are Abhimanyu, Jaykaran, and Sindhu. The objective is we want to explore scalable architectures and efficient techniques for performance optimization in resource constraints environments. That's when we chose EfficientNet model, which is already a resource constraint efficient model. And we would like to see how optimized we can make it for a particular classification task. And the task which we chose here is dog breed classification. Taking a deep look into dataset, we have about 10,222 images, and we have a diverse breed diversity, which has 100 plus distinct dog breeds. With the minimum samples per breed was about 66, and the maximum samples per breed was 126. And an average samples per breed was approximately 85. We have split the dataset into train validation test with this. This is how the dataset analysis for different dog breeds would look like. We would say it's still a balanced dataset due to a uniform flow. This is another image which we can see that the images of dogs are differently mentioned, and we have a unique count of 10,000. We have a count of 10,222, as I explained before. Looking a little into EfficientNet model details, this model has 7 different types of models, and we have chosen specifically model B2. And the performance of this model is significantly good, and which has only fewer parameters and flops across various benchmarks. This model is actually trained on ImageNet dataset. We chose this as our base model. This is a quick look into the architecture of the model. Coming to our methodology, we have included two optimization techniques. One is pruning, and the other one is quantization. In pruning, we specifically chose unstructured pruning. Unstructured pruning is basically we select few neurons and set them zeros, basically making their weights into zeros to induce some sparsity. As we know, FP32 and FP32 multiplication is it's much compute intensive than you multiplying it with zero. So inference time would be improved in this case. With regard to quantization, we have taken FP16 half precision. All the FP32 precise weights have been converted into FP16. Disclaimer is that we have applied everything after the training, so we don't have any separate training accuracy for the optimized models. So choosing the baseline, as I mentioned, we have used EfficientNet B2. We have trained this model at 0% pruning or quantization, and we have chose our data set. We have used Adam and cross entropy loss function and for 10 epochs. We have received about 98% train accuracy. Test accuracy was about 968, and model size was about 59 MB. Implementation flow is simple. We prune the model and quantize the model after we finalize a baseline. For different pruning ratio, we have generated quantized models. Let's say for 10%, 20%, 30% until 80% prune. For every pruning level, we have decided to create FP16 quantized models. This is a quick repack on the dynamic visualizations. This graph shows that the accuracy changed for FP16 and FP32 models after 40% of pruning percentage. As you can see that after pruning percentage at 40, there was a steep decrease in the accuracy, which makes the model perform very poorer. So we would say this could be the sweet spot, because at 40%, if you freeze your model, you still have acceptable accuracy and you still can use it for inference purposes. And at the same time, if you can see, there was a reduction in model size as well. It was almost half. This was about 55 and this was about 20. which is FP16 model sizes. This is a quick recap on how the accuracy was changing. Would see after 40, it was a steep decrease. That's why we consider 40 as the sweet spot in our case. And as you can see, the model size was reduced by half. This was another graph which we have included. So from our experiments, we can conclude that 40% prune model, FP60's quantized model, is good for making accurate predictions and is the sweet spot for our dog breed classification. Thank you.